Let's take a look at step one of your project. So, here you are inside your Canvas course. I'm using a training course. So here's, we'll say Math 110 with another section number. But this is generally how it's going to be structured. And, here on the right-hand side, you have all the submodules inside of the Canvas course. And you want to look at this module here called Project. And actually, you might be looking at it and it might look something like this. And so it might be kind of hard to find the project in all of this. So what I would suggest that you do is hit this button that says Collapse All. All right. And what that'll do is that will kind of shrink each of these, and you can now expand any module you want. So the module that you want to expand is this project module by hitting this little left triangle here. And now this shows you all of the steps for your project. Okay. So before we get to step one, let me again just kind of highlight the student project report guide. If you click on this, this gives you a link to a PDF file. And this PDF file you can download onto your computer or device and read the contents of that project guide. I've kind of given a quick little synopsis of what you can find in there. I'll be referring to one of the pages in there here in a minute, but let's go back. Okay, so here we are in the project submodule, and we're going to go to step one. And in step one, this is where you choose your data set that you want to use in your project. So click this link here down below. And here I've included some instructions as far as where you go to choose your data set and how you go about doing it. Okay. So what you can do is first click this link, which is going to take you to the DASL database. All right. So if you click this link, it'll open up a new tab that looks like this. All right. So this is the website. If I go back to my Canvas course or your Canvas course, you can see I've included a screenshot from the website. Okay, so this is just a screenshot to help you. So now that we're here, we want to go to a field that says search by statistical method. And if you look at this screenshot, you can see on the right-hand side, I've got it circled here, search by statistical method. And we want to put in correlation and we want to put regression. So let's go back to the DASL tab here in our web browser. And here on the right-hand side is where we have search by statistical method. And so what we're doing is, let me kind of tell you what's going on. So this website is a library of data sets. They've got thousands of data sets here. But what we want to do is, I don't want you to look through thousands of them. I want most of them to not be chosen by you, because a lot of the data sets won't work well for you. So in order to narrow down your choices to something that's easier to look at and is more manageable, we're going to search for certain data sets that are going to meet our needs. And so right here in this field where it says search by statistical method, if you left click there, it's going to give you a drop-down list. And in this drop-down list, we want to scroll down until we find the word correlation. Let's see here. Did I miss it? There we go, correlation, right there. So it's in alphabetical order. So I'm going to left click on correlation. All right, and right away you'll see that there's been a change, and that now we're starting to see some of those data sets show up on the left-hand side, okay? Because it's taken the thousands of data sets that they have, and now we've filtered those thousands down to 80 that will work with this kind of statistical analysis, okay, which is what we're going to be doing in this class. To narrow this down even more, what we want to do is we want to click on this again. So don't click on the word correlation, click in the blank space to the right of it and scroll down the list until you get to regression, which is right here. So if we left click here, now it's filtering the library of data sets for those data sets that will allow correlation and regression analysis. Okay. And you don't really need to know what that is at this point, but just know that this is what we need to do in order to filter down the number of data sets from thousands down to 66. So we have 66 data sets to search from, to choose from. And in a class of 30 students, that's plenty. All right. The next thing we want to do is I do want to limit maybe the amount of data that you have to work with. All right. So right now we are looking at data sets that have as low as 4 rows of data in them and as high as 118,720. Okay, this is too low and that's too high. So let's narrow down the range. So the minimum number of rows of data I want you to work with is going to be 25. So I think if you click in here and if you backspace, yeah, then you can just type in whatever number you want. So now we have a minimum number of rows of data or a minimum number of datums in our data set is going to be 25. Now the maximum, let's set this to 200. Now, if you want to, you can make this higher. So instead of 200, you could do 500, for example. It's not going to make your life harder because the spreadsheet software you're using can handle 500 rows of data as easily as 200 rows of data. All right, so that's not going to make much of a difference. This just might give you a few more data set options to choose from if you don't like what you see between 25 and 200. Okay, so now that you've chosen a minimum number of rows of data and a maximum number of rows in a data set, now it's time to actually look through the list of data files for one that interests you. So you can scroll down and you can see each of these data sets that looks like they're on different topics, carbon footprint, something to do about cars, something to do about companies, congestion cost, consumer spending, cramming, crocodile lengths, depression in the internet. And at the very bottom, when you get to the end of the list, there's actually 3 more pages of data you can choose from. So right now we're looking at the data sets, all the data sets that are available on the first page. All right. So let's take a look at some of these. Let me show you an example of a good example. Okay, a good data set, and let me explain to you why it's good. So let's look at crocodile lengths. So what I'm going to do is I'm going to left click on the crocodile lengths word here. I'm going to left click. And this is going to give me a little bit more information about this data set. So where it says number of cases, it says 32. This means we've got 32 rows of data. And 32 is more than our minimum of 25. Okay. And in this case, it does give us a little bit of background as far as the context of this data set. So it says the ranges inhabited by the Indian gharial crocodile and the Australian saltwater crocodile overlap in Bangladesh. Suppose a very large crocodile skeleton is found there, and we wish to determine the species of the animal. Wildlife scientists have measured the lengths of the heads and the complete bodies of several crocs in centimeters of each species. So if we scroll down a little bit more, this gives us kind of an idea of what this data set looks like. So this is a data set that has three random variables. Okay, a body random variable, a head random variable, and a species random variable. So these two are numerical, and this one is categorical. Okay, so this is like a really nice data set because it's pretty straightforward. Okay, and what do I mean by straightforward? Well, when it talks about head, it said that it was the length of the crocodile head. So maybe from the snout to the back of its skull. And they tell us that it's measured in centimeters. So we know that this 24 means this Australian crocodile had a head that was 24 centimeters long from snout to maybe the back of the skull. Now, the body, it doesn't really tell us too much about the body. So we have to use our imagination here. Let's say that the body is going to be the length of the body, maybe from the snout of the crocodile all the way back to the tip of the tail. And that's in centimeters. So that would be 161 centimeters. So, you could think of this as being like, the length of your head and then the length of your body. Okay. So this data set, even though it's about alligators, I think it's maybe easier to understand what this data represents. It's easier to imagine. Okay. And what you need is you need at least two numerical random variables. You need two columns composed of numbers that you're going to be doing an analysis on. So this data set meets that minimum. Okay. Another thing that we want to look for is it's going to be nice if our numbers that we have for our random variables, if they're over one, okay, they're higher than the number one. And here we've got numbers that are in the hundreds. Here we've got in the tens, the 20s, the 30s. Okay. So we have values that are greater than one. These are just really nice, easy numbers to look at and work with. Okay. So this is actually like a really good data set to use. And maybe I'll return to this one. But now that I've kind of talked about why this one is so good, let me go back and maybe show you some examples of ones that I would not use. So one, for example, would be this one, which is depression and the internet. So let's click on that. Now this is nice because it does give you some context. Okay, and I'll kind of let you read that here. But what I want to come down to is I want to come down and take a look at what this data set is composed of. Now, there are some things in here that make sense. They've got gender, so they've got male and female. They have age, adult and teen, that makes sense. Household income, this is in thousands of dollars, so 62,500, 85,000. Okay, that makes sense. Household size, how many people were in a household. But look at these two columns here. Okay, this data set is about depression. Okay, what do these numbers represent? I understand, that this means there are two people in a household. This is five people in a household. But depression before 0.7999, what does that mean? Okay. And if you kind of read this context here, it's really kind of not clear what these numbers mean. And if you're going to be working with numbers in your report, work with something that you understand. Now, maybe you're a psychology major and you know exactly what this means, then go for it. Okay. But I myself, I would have to do some extra work to figure out what this means. So, given that I've got enough things to worry about, I think I would pass on this one. All right. So for number one, I would kind of pass on this data set just because I don't really know what depression before and depression after and what these numbers represent. I don't know. Okay. Number one. That's the reason why, number one, I would not choose this data set. Number two, the reason why I would not choose this data set is these values are less than one. Okay. And it doesn't mean you can't do statistical analysis on values less than one, but I'm trying to make this simpler and easier for you. And if you use numbers that you're going to have to round at some point, that you're going to have to put these numbers on a graph, these numbers are going to be relatively large and it'll be harder to fit them on a graph. Okay. So that's why I suggest that you work with values that are going to be greater than one. If you remember, like the crocodile lengths that I just showed you, the head size was 25 centimeters, 35 centimeters, 37. See, those are all values greater than one. These are all less than one. Okay. So for the purposes of this project, this would not be like an ideal data set. Okay. All right. Let's go back and let me find another one. I think that would also not be a good one. Cramming. Let's look at this one. So it's got an explanation here, but even given this explanation, okay, it does have two columns of data, two random variables, but it's just not really clear what Friday and Monday means. What does that mean? You know, I read this description and I wasn't really too clear on what these numbers actually represent. Okay. And if I don't know what they represent, how can I explain them in a report? I can't. So it does have some nice numbers that are above one, but then I don't understand what this is talking about. So I would skip this one as well. Um, Let me see here. Let's look. Let's see if there was one here. Maybe it was consumer spending. Let's look at that one. Consumer spending, again, we're dealing with some numbers that, are greater than one, some are zero. So that doesn't look good for us. And again, not really clear what February, March is referring to. So I would skip that one as well. Um, let's see, cramming, computer spending. Let's look at, looks like it's alphabetized. See how each of these start with C and then D. Let's look at this one, Dow Jones. Okay. This is also a different type of data set to avoid. All right. Now remember, you want a data set that has at least two numerical random variables. And so this appears to have two numerical random variables. You've got year and you've got whatever DJIA average close is. Okay. Oh, Dow Jones stock index. Okay. So this is the Dow Jones index. Okay. That makes sense. Um, and year makes sense. But we do not want to, um, we don't want to choose a data set that has a year column like this, at least where the year column is going to be one of the random variables that you're going to have to study. Okay. Because this particular data set, which has a one column of year and one column with some other numerical random variable, this would be called a time series graph. And we're not going to be doing a time series graph in our analysis. Okay. So this would not be preferable. Okay. Just because there are only two columns and one of them is a column of data that you can't use. Okay. So anytime you see a year column like this, and it has years that are separated by 1 year or 2 years or whatnot, I don't want you to use this column in your analysis. All right. Um, so let's go back and let me show you one more example. Let me go to the second page and let's scroll up to this one, which is El Nino. And this one would be okay. Now, in the previous example, I said, don't use it because it's got a year column. Okay. But remember, the last one only had two columns of data. One was year and one was the stock exchange index, right? But you see, this data set gives you more random variables. So you can kind of ignore this year column and you could choose this column, as a random variable you're going to analyze. And you could choose this one, which is the second column of, of data that you're going to analyze. So because this gives you more options, namely these two, you can kind of ignore this one or not use it. Okay. So uh, that would be an example, of where this one would be okay, but the stock index one would not be okay. All right. And I think that kind of covers all of the bases as far as, what would be a good data set to choose. Again, try to use one that makes sense to you. All right. Um, so let's say, for example, you wanted to use this El Nino one. Okay. You've decided, I'm going to use this El Nino one. CO2, this is probably parts per million. So I know the units are going to be parts per million. Mean temperature, that's average temperature. This is probably degrees centigrade instead of degrees Fahrenheit. So because I think I understand what these two columns of data represent, I'm going to go ahead and use this one. So, um, so what we need to do is you need to claim this data set for yourself. So what we'll need to do is, let me go back to the Canvas course, and under discussions, I created a pinned discussion called student project. And so this is where you publicly go to claim your data set because no two students can have the same data set. So when you reply in this discussion, it's going to date and timestamp your reply. And when we fill that reply with your data set information, that'll make it, non-debatable that that data set is yours. So I'm going to go ahead and click reply to reply in this discussion. And the first thing I want to do is I want to paste in a screenshot of the data set. So I'm going to go back to the DASL website. And here I'm in this El Nino. And so I don't know what it is on a Macintosh, but if I hit three keys together on Windows, if I hold down the Windows button, the Shift button, and the S button, you can see that the screen kind of goes dark a little bit, and my cursor changes to like a cross. And now if I take this cross and I hold and drag the mouse button, I can drag a box kind of around the top and include just a few rows of data. just a few. And then as soon as I let go of the mouse button, it has now copied that window that I just drew. And if I come back in to the discussion and I can right click and choose paste, it pastes that screenshot that I just made. Okay, so you see how that was just the rectangle that I just drew? Okay, it copied that and I just pasted it in. The other way you could paste it in, let me go back. I think I could just go to edit and choose paste. Nope. My browser doesn't support direct access to the clipboard. All right, thank you. So I'll just hit Control V for paste. All right, and put it back. All right, so that's the first thing I got to do is paste in this picture, claiming this data set is mine and showing that this is what the data looks like. These are the random variables in the data. The second thing I want to do is I want to attach the data set file to this discussion entry, this discussion reply. So we'll go back to the DASL website, and you see next to where it says El Nino, there's this link that says download text file. So I'm going to left click on this. And what it's doing now is it's prompting me to save it. So here's the text file. It's called El Nino 2017 because that's the data set I'm in. And I'm on my computer, Drive C, and I've got a directory called temp2. And you can see I already saved like a previous data set here. But I want to save this El Nino one. So I'm going to click save. I'm going to save it to this directory. Okay, and it told me it saved it there. So now I'm going to go back into Canvas. I'm going to hit attach. And now I'm going to go to my C drive, the temp2 directory. Here's that El Nino data set that I just saved. I'm going to click on it and choose open. And you can see down here, now it says El Nino 2017. And now I can hit reply. And you can see now it's got my name. It has the date and the time. So we have a date and time stamp for when I chose this data set. And here's a copy of the data set file down here. Okay. So this helps me because if you have a question about your data set, I can look at this really quick and I can see, okay, so-and-so has this data set and this is the data that's in it. And the questions you're going to be asking me are probably related to how do I do this in the spreadsheet software? So I need access to the data set itself. And so you've already attached it. So I can download this data set, I can import it into Excel or Google Sheets, and I can help you. Okay, so it puts both in one place. So just remember, other students will be pasting, they'll be replying. Don't reply to them. Start here at the top. And when you first see this reply button here, click that and add your reply to this student project claim your data source discussion. Okay, let me go back. Yeah, and so that is step one. That's what you need to do in step one is to choose and download a data set and claim the data set in the discussion. All right, let me know if you have any questions.